Hi, welcome to Math 1400, Nunez Community College. This section is section 1.7, which are inverses of the trig functions. So we take our sine, our cosine, and our tangent, and when we invert them, we swap the domains and the ranges. So this is the definition of the inverse trig functions. The first thing is we have y equals arc sine of x, and arc sine means the same as sine -1 of x. These both represent inverses. This would be the inverse of cosine, either one. This would be the inverse of tangent, either one. And since we flip them, if we remember what the graph of sine is, it only goes up to 1 and down to -1 in the sine wave. So that becomes our domain of the inverse, where it's -1 to 1, where x is in between. Same thing with the cosine. When we deal with the tangent, remember the tangent had asymptotes, so it went from -infinity to +infinity. So the domain becomes -infinity to +infinity, which was the range of the regular tangent function. The ranges now are going to be restricted for the sine, because we don't have an inverse if the y would repeat. So we restrict it from -π/2 to π/2. The range of the cosine would be from 0 to pi, and the range of the tangent would be from -π/2 to π/2, but because it doesn't exist on regular tangent, we would not include it on the range of the inverse. So we come back over here to our unit circle. And that premise is what we're going to have for these answers. So basically what it says is the inverse sine only exists between this range. So the inverse sine is going to be restricted to quadrant 1, which is the π/2, down to quadrant 4, which is -π/2. So that's how we restrict the range. The cosine is going to be from 0 to pi. So the cosine would be somewhere in this area, the inverse. And the inverse tangent, just like the inverse sine, is going to be in this area. So sine and tangent is going to be restricted to quadrant 1 and quadrant 4. And cosine is going to be restricted to quadrant 1 or quadrant 2. So how are they going to ask us to find this? They would say something like, find the arc sine of, in this case, -1/2. Find the arc sine of -1/2. So in essence, if I turn this around and made it a sine, I would put this as theta, because we're trying to find the angle where the arc sine is equal to this. So this literally would be the inverse sine, because they're interchangeable, I can swap them either way, of what angle is equal to -1/2. If I wanted to rewrite it, If I wanted to rewrite it and I swap these two, that would be sine of what angle equals -1/2. Well, if I'm looking for the angle, I would have to bring the sine to that side, so that's the inverse sine, -1/2, which is what we're looking for. So I'm looking for what angle is the inverse sine or the sine equal to -1/2. Since the sine is restricted, the sine is going to be either the first or the fourth quadrant. If it's negative, I know we're looking in the fourth quadrant because the sine is the y value. The y values in the fourth quadrant are negative. I look for where my y value is -1/2. It's -1/2 here. So my theta that we're looking for is going to be this angle, which is -π/6. So that's what we're doing here. We're looking for the arc sine or the inverse sine, where it's equal to that amount, and we're looking for the angle that represents that. Looking for the angle that represents that. So if I have the inverse sine, I can write it as inverse sine of the square root of 3/2, square root of 3/2, that would be equal to theta. So therefore what? That means the sine of theta is square root of 3/2. So theta would be, in this case, where is the sine going to be positive? Well, we're going to have the inverse sign positive in the first quadrant. So we're looking for where does the y value equal square root of 3 over 2. It equals square root of 3 over 2 up here. And this represents what? Theta is pi over 3. Theta would be pi over 3. Suppose we're looking for the arc sine of 1, which is theta. That's what we're looking for. So in essence, we're looking for the sine of theta is equal to 1. So theta equals sine inverse of 1. And sine would be 1, where the y value is 1, right here. So theta would be pi over 2. Theta would be pi over 2. If they gave us an inverse sine of 2, well, we're looking for where the sine of theta equals 2. And the sine of theta can equal 2, but the inverse sine of 2 we can't have because the domain of the inverse has to be between -1 and 1. So therefore, this would be the null set. So we have to have anything that we're looking for has to be within the domain, which is -1 to 1. Has to be within the domain of -1 to 1, and the answer is going to be the angle, which has got to be between -pi over 2 and pi over 2. Hence the reason it's in the first or fourth quadrants. So when looking at this and doing it, we can also find the cosines and the tangents. We just have to know what we're looking for and where we're looking for it at. So the cosine would be in quadrants 1 or 2. So if the inverse cosine is a positive number, we're looking in quadrant 1. If the inverse cosine is a negative number, we're looking in quadrant 2. So suppose we have the arc cosine of square root of 2 over 2. So that means we're looking for angle theta, where the inverse cosine is square root of 2 over 2. Well, cosine is positive. Cosine is positive in the first quadrant. In the second quadrant, cosine is negative. So the cosine is the x value. Where's the x value square root of 2 over 2? Right here. This angle that we're looking for is pi over 4. That would be our answer, pi over 4. So remember, if they're positives, they're going to be in the first quadrant. If they're negatives, inverses, then the sine and the tangent will be in the fourth quadrant. The cosine will be in the second quadrant. Suppose I have the cosine inverse of -1. The inverse cosine of -1. Again, remember, I'm using both of these because both of them mean the same thing. Sometimes you'll see one version, sometimes you'll see the other. So I'm looking for what angle theta is the inverse cosine equal to -1. Well, I know that the cosine is the x value. -1 for the x value is going to be where? -1 for the x value is going to be at pi, because I'm looking for the first or second quadrant. So theta would just be pi. Theta would be pi. Suppose I'm doing the tangent. Again, they're all the same. It's just what quadrant you're in order to find that angle. Suppose I have the arc tangent of 0. The arc tangent of 0, which means what theta has the inverse tangent, which is 0. Now I know that the tangent is going to be what? The y over x. So I'm looking for where is y over x going to give me 0. And y over x gives me 0 here, where y over x would be 0 over 1. So in this case, theta would be 0. In this case, theta would be 0. Okay. Suppose they ask us to use a calculator to find. Suppose they ask us to use a calculator to find. So we're going to have to 4 decimal places. To 4 decimal places, we're going to find the inverses. For instance, the inverse tangent of negative 0.8, negative 8.45. Negative 8.45. In our calculator, we're going to hit the, by the way, make sure it's in radians, because this is radians, it's not degrees. We're going to hit the tan -1 button. We're going to punch in negative 8.45. We're going to hit enter. And we should come up with negative 1.4530. Negative 1.4530. Make sure that you're punching this. Make sure you're coming up with the exact same figure, because you could be punching something wrong. You could have it in the wrong mode. Make sure that your calculator is giving you that same number. Suppose we're looking for the inverse sine of 0.2447. If you punch it in, you hit enter, and you did it right, we should be looking at theta is approximately 0.2472. 2472. Suppose we're looking for the arc cosine of 2. The arc cosine of 2, which is the cosine -1 of 2. If we punch that in the calculator, you would notice that what? We come up with error. Error function. Why? Well, because the domain of the inverse is what? Between -1 and 1. 2 is not within that, so therefore it's the null set. Therefore, it would be the null set. We now have some problems where we have the function of its inverse, or the inverse of the function itself. And our rules will look like this. If we have the sine of the arc sine of x, so the sine of the arc sine, or the inverse sine of x, the answer is just x. If we're within the domain, which is from -1 is less than or equal to x, which is less than or equal to 1. If we go backwards and we have the inverse of the sine of x, inverse of the sine of y, because now we're looking at the range, we are equal to y. And that's if -pi/2 is less than or equal to y, which is less than or equal to pi/2, because that would be the range of our inverse. If I'm looking at the cosine, again, the cosine of the inverse cosine of x is equal to x, but for the cosine, it's the same between -1 and 1 because of the graph. And if we're having the inverse of the cosine of y, it's also equal to y, but the cosine is, inverse cosine is restricted to 0 to pi. So again, the same as long as it's between 0 and pi. And the tangent of the inverse is equal to x always, because the tangent goes up to its asymptotes from -infinity to +infinity. So whatever number we have here, we're not restricted like we are with the sine and the cosine. Whereas the inverse tangent of the tangent of y would be equal to y only between negative pi over 2, which is less than y, not less than or equal to, because this would be where the asymptote would be, and that is less than pi over 2. So, in a nutshell, if I ask the sine of the inverse sine of anything in between here, for instance 0.5, then the answer would just be 0.5. If it's the cosine of the inverse cosine of anything that's within, so 0.75, then the answer is 0.75, as long as it's within. And if I'm trying to find the sine of the inverse sine of something greater, again, it's the null set because it's not within the range. And the tangent though would be anything. The tangent of the inverse tangent of anything, of 7 would be 7. Because again, it's not restricted. It's not restricted. And on the other side, if I have the inverse sine of the sine of anything within, so pi over 4, then the answer would be pi over 4. But it has to be within the range. Okay, suppose we had, let me erase this in 1 second. And suppose we had two different functions. So the inverse of one function and of the actual different function. One more, and we'll be done. Okay. Suppose we have the tangent of the inverse cosine of 2/3. The tangent of the inverse cosine of 2/3. And we're looking for, what angle are we looking for? Okay, we're looking for what is the value. So what do we know here? I'm going to take it and just look at this part. And since this is not one that we know, we're going to have to draw it in the right quadrant as a right triangle. So I'm looking for the cosine of theta equals 2/3. When I rearrange this, it's the cosine of theta equals 2/3. Well, we know one thing. Since it's the inverse, I'm looking for restrictions, meaning I'm either in the first or second quadrant. Since this is positive, I know that the cosine is in the first quadrant, so I'm going to draw my right triangle in the first quadrant, this being theta. And the cosine is 2/3, which means it's what? Adjacent over hypotenuse. So this will be 2, that'll be 3. We need to find the third side. So I got what? 2 squared plus y squared equals 3 squared, 4, plus y squared equals 9, and we come up with y is equal to the square root of 5. Take the square root of both sides. So y is the square root of 5. Why did I need that? Because what we're trying to do is, this is the angle, so I'm trying to find now where the tangent of theta is equal to, the tangent of theta is equal to what, if that's my angle theta? The cosine of that angle is 2/3, so the tangent is now going to be what? Opposite over adjacent, or square root of 5 over 2. So that's what I'm looking for. The tangent of that angle is square root of 5 over 2. So again, with this, I'm taking it, using it just as that portion. I'm finding with the cosine sine, whatever it is of that angle, I'm drawing it in that quadrant, and then I'm going to use Pythagorean theorem to find the missing part so I can find the other function I'm looking for that angle. So if I'm looking for the cosine of the arc sine of -3/5. Okay, well, I know that what? The arc sine, this would be equal to what? Theta. So I'm looking for where the sine of theta is -3/5. Since it's the arc sine, I know I'm restricted to either quadrant 1 or 4. Since it says negative, I know I'm in quadrant 4. I'm going to draw the sine in quadrant 4. And I know that sine is what? Opposite over hypotenuse. Now I can find the missing side, because what I'm trying to do now, once I've done this, and this is theta, I'm now trying to find what? The cosine of that theta. The cosine of that theta. So the cosine, I'm going to have to use Pythagorean theorem. -3 squared plus, well, x squared plus -3 squared equals 5 squared. That gives me what? X squared plus 9 equals 25. X squared equals 16. X equals 4. So it's a 3, 4, 5 right triangle. And the cosine of that angle would be what? Adjacent over hypotenuse. So the answer would be 4/5. So again, we broke it into 2 separate problems. This one first, so we could draw our triangle and figure out our missing part, so that we then could do the other function of that angle. And the answer would be 4/5. And then finally, suppose we have something like the secant of the arc sine of 5/13. 5/13. Again, one more time, I have to erase the board because I'm out of room. Okay, so what do I have to do first? The first thing I have to do is not equal 0 equals theta. So the first thing I want to do is isolate this part, and I'm looking for where is the sine of theta equal to 5/13. Well, sine being in the first quadrant, because it's positive.
Alexis Brown to the front office.
I'm going to draw this. Got my theta. Sine is opposite over hypotenuse, so that's a 5, that's a 13. I'm going to use the Pythagorean theorem in order to find the missing part. This is going to be 12. 5 squared plus x squared equals 13 squared. X equals 12. So now I'm going to look for the secant. And the secant is what? Secant is the inverse of the cosine. Cosine being adjacent over hypotenuse, so the secant is the hypotenuse over adjacent. So the secant of this angle theta, hypotenuse over adjacent, is 13 over 12. And that would be the answer we're looking for, 13 over 12. And that really concludes section 1.7, which is inverses, which you just have to remember, again, is that when we're doing an inverse function, that we are restricted the domain, and the range tells us what quadrant that we're in. Whether it's the sine being first and fourth, whether it's the cosine being first and second, or whether it's the tangent being first and fourth. That concludes section 1.7. I'll catch you at the next one.